Hey Algebra 2 friends, sorry I'm not there with you today. It's Monday, it's March 14th. It is technically Pi Day today. We will celebrate tomorrow in class. So patience, and I'm so sorry I'm not there to celebrate with you. Tomorrow our plan is to get our tests back, review, try to catch some of our own mistakes, and start looking towards any petitioning or correctives that we need to do before the end of the marking period on Friday. As for today, though, we will be looking at a little bit more in your matrix packet. So we're going to talk about matrix addition and subtraction today. You already should have a Chromebook. You should already have headphones plugged in. Find your matrix notepad. Have a pencil or a pen out in your matrix notepad. Stay in your assigned seats. If you finish early, feel free to do a little bit of online practice, or you can work on that organizing data worksheet that should be in the pickup station for you. Tonight, whatever you don't finish here in class, I ask that you finish just the first side of organizing data into matrices. There is some more practice on the back side. It's about dimensions and elements and augmented matrices. So some quick practice that you should be able to finish as well. It's just some more practice from Objective 1. It's a short objective. We already have it all taken care of, so it's just good to get some practice in. By the end of today, you should be able to add and subtract matrices together. There are times when you can and can't add or subtract a matrix, so you should be able to determine if it's possible. If it is possible, you should be able to add and subtract individual elements and write your final answer as a matrix. We're going to look at pages 4 and 5 of the notepad to make sure this happens. So let's go ahead and flip to page 4. And some vocab to begin with. A zero matrix is a matrix where everything inside that matrix is a zero. So we're looking at something where it doesn't matter what size it is of a matrix. It could be any number of rows and columns, but every single thing inside of it is a zero. If you add or subtract a zero matrix from another matrix, it doesn't change any of the values. It's just like if we were to say 4 plus 0. Well, adding 0 to something doesn't change its value. We get the same thing in that we got out, because the 0 adds nothing. Same thing if it were just subtraction here instead of addition. If it were 4 minus 0, 0 doesn't change any value. A matrix equation is an equation that means it has an equal sign, where the variable is a matrix and we have to solve unknown elements of an unknown matrix. That would be like if we had a matrix over here and we said plus some big giant unknown matrix, we'll call this one M, equals another matrix over here. And if we know what those numbers are inside, 1 and 3 and 0, 7, and we're adding some certain things, and we come up with an element over here, 4 and 10 and 2 and 5. We should be able to see that this is a matrix equation. We have a whole entire matrix that goes in here. There's an equal sign, so it's an equation. We would have to figure out exactly what those 4 elements would be in this matrix to make this statement true. Equal matrices, it makes sense it has an equal sign. They're matrices with the same dimensions and equal corresponding elements. This means that if we have two things that are equal to each other, what we have in one is the same thing that we have in the other. Now this is going to be important, especially as we start working a little bit later on. If I know something like this is a 2, this is a 2, this is a 7, and that's a y plus, 3 or something. Sorry, this is so bad writing because it's my right hand and it's on a computer and it's the weekend, so I'm not really thinking about math right now. This maybe we'll make it a 0 and we'll make that z. So by knowing that equal matrices are the same, what we have in position 1, 1 has to be the same in the other one, position 1, 1. So x has to equal 4 in this equation. Position 1, 1, position 1, 1. Here, 2 equals 2. We already know that. That's all set to go. Here, 7 equals y plus 3. So if we think, what would y have to equal if 7 equals y plus 3? Well, let's see. Something plus 3 equals 7. Maggie, what would that something have to be? It'd have to be 4. I don't know if you heard her say that, but she did. So that's what we can learn about equal matrices. Going down a little bit more, let's figure about adding and subtracting matrices. To add them, the first thing that we need to know is that they must have the same dimensions. It is required. If they ever don't have the same dimensions, we cannot add, we cannot subtract. All right? So it has to be something that has the same number of rows, and they also both have to have the same number of columns. If they don't have the same number in rows and columns, so if not, same dimension, let me just turn on the typing here because it's almost easier that way. There we go. If not the same dimensions, our answer or our solution is not possible. We could also call it you're going to see it on your calculator, something that looks like this. It's called a dimension mismatch. So I have to first of all make sure that I've got something like the same exact dimensions first. So this here is 2 rows, it's a 2 and 3 columns, it's a 2 by 3 matrix. And if I wanted to add or subtract it with B also has 2 rows and 3 dimensions, it's a 2 by 3 matrix. They have to match before we can add or subtract. If they don't match, it makes sense. Our dimensions are mismatched, so it's a mismatch. They're not possible. We can't add or subtract unless they're the same. And then what we're going to see is we're simply going to add corresponding elements. Element 1, 1, I'm going to add it to 1, 1. So it would be A plus R. Dimension the element that's here in location 1, 2, first row, second column, 1, 2, B and S. To add those together, we're simply going to add B plus S. First row, third column, in the first matrix is C, and we're going to add it to the same element in the second matrix, T, C plus T. We'll complete this with every single one of our matrices, every single one of our elements that's in here. D plus U is over here. And then for our last couple elements, what we have is something like E plus V. And last but not least, F plus W. Now, of course, when we have a matrix, it's not a real matrix, still we put it in brackets. So we got to put our bracket on the outside, and we're going to put our answer like that. So think of each corresponding element, we're going to add them together. I bet you're already making predictions about how we subtract matrices. You're probably right with your prediction. So let's do a couple of practices. Let's add some matrices. Oh, look, a 0 matrix. If it's a 0 matrix, we just said that it's not going to change the value at all of what we begin with. So when we add these two together, we will in fact come up with a matrix that has the same value as our original matrix because this doesn't change it at all. So we're finding something like a 9, and then a 0, and then a -4, and a 6. And it's not a matrix until we have brackets around the outside of it. Well, that was nice and easy. I like 0 matrices. I hope you do too. Over here in this practice, we're going to see that we're going to start looking at our corresponding elements. We're going to add them together because it tells us we have addition in the middle. It's a 2 by 2 matrix here, 2 by 2 matrix here. I can add them together. So 3 plus negative 3, oh, that's a 0. Negative 8 plus a positive 8, oh, wait a second, that's a 0. I think I see a pattern going on here. Negative 5 plus a positive 5, 0. What have I not used? Blue. And a 1 and negative 1. When I add those together, I get 0. So what I'm seeing here is that actually my result can be a 0 matrix as well. That's interesting. All right. Let's try something a little bit bigger here. Something going on. Looks like we're adding these two together. I check. It's a 2 by 2 matrix. Adding a 2 by 2 matrix. I can add these. I'm making a big point of this because I don't think I have an example where I couldn't add. That's odd. 198 plus 54. 8 plus 4 is 2. Carry the 1. 9 plus 5 is 14, plus 1 more is 15. 5, carry the 1. I'm doing this backwards and upside down. 252. It's probably painful to watch me have to type or write so slowly. 350 plus 439. Let's see, 0 plus 9 is 9. And 3 plus 5, 5 plus 3 is 8. And 3 plus 4 is 700. There we go. That's a nice one. 201 plus 58. So I'm going to take that 58. I'm going to add 201. 259. And last but not least, 375 plus 386. That's a 1 here, carry the 1. 15, 16, 6 here, carry that 1. 3 and 3 is 6, plus 1 is 7. Look at that. Matrix around the outside, brackets, brackets, brackets every single time. Hey, hit pause. Try these two on your own. When you have it done, unpause and you'll see these answers here. So pause now. That's funny. I put hit pause on my recording too. That's kind of silly. Alright, so when you unpaused, I'm hoping that you have it all set. Here's our answers and what we should be looking at. Watch those negatives. Same things apply with the negatives. If I have a negative 12 and I'm adding 3 more negatives, I get a negative 15 going on here. Okay? Double check your answers. If you got it, grab the shoulder of the person next to you and say, yes! And they probably won't know what you're talking about because maybe they haven't gotten that far in the video.